to 99. Particle motion 2, because we already did particle motion 1. So, I have a note up there, just kind of, if nothing else, it's as a reminder for myself to make sure I talk about it. And if I don't have it written down, I tend to forget. So I've started writing it in my notes each year so that I remember. But we're talking about particle motion, okay? Remember, this is where you're talking about position, velocity, and acceleration, right? Okay, so, right. So, my comment up there is kind of should be a starred comment, I guess, but the definite integral of the velocity function of a particle moving along the x-axis. So, this is particle motion. So, this is where we're moving left and right along an x-axis. So, forwards and backwards along an x-axis, right? But the definite integral of the velocity function of a particle moving along the x-axis represents the algebraic sum of left and right distances traveled by the particle. So anytime you're moving left, that is a negative value. Anytime you're moving right, that is a positive value. Okay, which, typical, right? You move left, it's negative. You move right, it's positive.
So it's not the total distance traveled. It's just the position on the x.
Right, yeah. Well, yeah, I guess, yeah, you could say that.
Back and then you travel forward.
Right. Yeah, no, we're not talking about, okay, we went 3 to the left, we went 7 to the right, okay, that traveled a total of 10. No, it's looking, and considering the negatives and positives. Okay, so as we look at this first example, the velocity function for a particle moving along the x-axis is v of t. The following is given. And I'm going to have to rewrite these numbers in because I can't read them and I don't remember what they're supposed to be. The first one is the integral from 1 to 2 of v of t dt is negative 7. The second one is the integral from 2 to 3. V of t dt is 3. The integral from 3 to 4 is negative 2. And the integral from 4 to 5 is 6. Okay, so those are the information. It's 1, 2, 2, 3, 3, 4, 4, 5. It's kind of faded out there. Okay, so the first question involving these integrals. How much does the position of the particle change over the interval 1 to 5? Essentially. Because so if we're going from 1 to 5, break it down into pieces, right? So what do we know? From 1 to 2, what does it do? Negative 7, which is a left 7. And then that's from time 1 to 2. Then from 2 to 3, what's it do? Goes right 3. And that is a positive 3. Then from 3 to 4, it's left 2, so it's a negative 2. And then from 4 to 5, it's a right 6 because it's a positive 6. So if you move 7 left, then you come back 3 right, but then you go 2 more left, and then you can come back 6 right. We end up at 0. What does that 0 mean then?
Doesn't change.
Yeah. You moved along the way, but you ended wherever you started. Okay. A word that I have written in here is it's the net change. Okay. We have a net change of 0, meaning overall we changed by nothing. Okay. B. If the particle is at x equals 7 when t equals 2, what is the position of the particle when t equals 4?
So you just add them together from 2 to 4, and then add that to 7, or move 7 by that much.
Okay, so notice, first of all, they talk about the particle starts at 7, yes? So that means that instead of just, starting off
Bless the ocean.
moving from 0, we're going to start at 7. But then we're going from t equals 2 to t equals 4. So we're going over the interval 2 to 4. So if we start at 7, what's the...
Bless the ocean.
That's right. If we start at 7 at time equals 2, and we're going to time equals 4, what's the first thing we do? Because from time 2 to 3, we're going to go right 3. So that's going to be a plus 3. And then what? From 3 to 4, we're going to go left 2. And then what? Okay, you add them all up. So we end up at 8. Which, what does 8 mean?
X equals 8 when t equals 4.
Okay, x equals 8 when t equals 4. In relation to where we originally started at 7, we are 1 to the right. That is our net change, so to speak, is we're 1 to the right. Are we okay with this? I did not do anything incredibly hard there yet, I don't think. Okay, let's try example 2 then. A particle moves along the x-axis so that its position function is x of t equals 2t to the third minus 9t to the second plus 12t plus 1. Can you guys read those exponents? Yeah. Yeah, 2t cubed minus 9t squared plus 12t plus 1. Okay, so what are the positions of the particle at t equals 0 and t equals 3?
Well, at 0 is x equals 1.
And how do we find that?
Plug it in.
Okay, so we want to know the position at time equals 0. And what are we given? We're given a position function. So if you want to know the position at time equals 0, you plug it in. When we plug in 0 to that function, we're going to get 1. Are you guys okay that I wrote that and didn't show how I got that? Okay. What about the position at t equals 3? It's doable.
It is. This was brain break today.
If I had the proper time, I could work it out.
Well, t cubed, 3 times 3 times 3, there's 27 times 2, 54, minus
81.
9 times 9, 81, plus 36, plus 1. My brain has gotten that far.
10.
All works out to be 10 is what I'm being told. Okay, questions on that one? It's just asking, nothing fancy there, right? Just what are the positions? You got that one?
I like it.
Okay. Well, and hopefully you realize technically this is leading up to, how we do, the full understanding of what we do. But
Let's just have a whole problem set.
okay, now B. Let's look at B. What is the total distance the particle travels between t equals 0 and t equals 3?
So we're going from 1 to 10.
So distance, not position.
Oh, wait, what? So we're not going from the 1 to the 10, we're going from the 0 to 3?
So do we have to go plug in 1, plug in 2, if it goes to a negative or to a positive,
Because we're doing distance and not position.
to absolute value and everything?
Sorry, I just thought I'd let you guys talk it out for a moment because I was like, okay, I can even answer so many questions. But okay, so first of all, realize up here 0 and 3 were times, right? 1 and 10 were positions. And now, and those were positions. So at time 0, we are located at 1. At time 3, we are located at 10. Now, does that mean from time 0 to time 3, we went straight from 1 to 10?
I went to check
Okay, what happened along the way?
You also crossed out 1 and 2.
Okay, and so what we technically need to do is we need to find out, were there any change in directions? And when does something change direction? When the velocity is 0. So this is putting it all together here. So we have a position function.
Okay.
Officially, we need to look and see when the velocity changed direction, because those are the times we have to see, okay, did we just start at 1 and travel straight to 10? We always move to the right, no change in direction? Or was there some changes in the direction where we went right, left,
Switching to the right and equal to 0.
Okay. So first thing we're going to do, in order to find velocity, we have to do the derivative of position. So x prime of t is going to give me velocity. So if you would, derivative of that function up there,
6t squared minus 18t plus 12.
6t squared minus 18t plus 12. I could go with that. Officially, we need to set it equal to 0. What do you guys see about all three of these terms? So factor, divide the 6 out. So if I factor the 6 out, I've got 6 times t squared t squared minus 3t plus 2 equals 0. And good news is that definitely looks like something I can factor. T squared is t times t. 2 is 1 times 2. Multiplying to be positive 2. Adding to be negative 3. Both negative.
So it changes at both 1 and 2.
Okay, set both parts equal to 0. T minus 1 equals 0. T minus 2 equals 0. We get times of 1 and 2.
So we need to find that both, take the absolute values of it all and add it. Subtract the 1.
Trying to figure out your add it to 3 comment.
Add it to time 3. No, time 3. Because it moves, I don't know.
Wait, why did we find 1 and 2?
Okay, so, 1 and 2 are the times when my velocity equals 0. And when velocity equals 0, that's your speed equaling 0, right? And so that's when so if I'm going to the left, then my velocity stops, then that is an indication that's where I turn and now I'm moving to the right. Velocity stops, turn it, like that's the time that I might be changing positions. So what we need to do is we need to figure out, we already have to know our positions at 0 and 3. We will also have to see what happened at 1 and 2. Okay, what our positions are. So what I'm going to go through and list.
So if I wouldn't have listed like the 2, and we already have 0 and 3, we wouldn't have had to look for 2, we would have just looked for 1.
Correct. Yes. So yeah, we have to know 0 and 3 because those are our beginning and ending points. Because we found times of 1 and 2, we're going to have to know those as well. So it just so happens to be we need 0, 1, 2, 3. You wouldn't always need all those. So we already know the position at 0 was 1, correct? Position at 1. What's my position at 1? Oh, it is. Okay, so x of 1 is 6. And we're plugging not into velocity, but back into the original, yes? We also need to know the position at time 2, because that's a velocity is equal to 0. So position at time 2, what's x of 2? Okay. 5?
Yeah.
It should turn out to be 5. That's what I've written down. And then we already know that x of 3 is 10, correct? So I wrote that out just for the visual.
So it has a distance of 11.
Hello? I do not, other than in the maintenance room, unless pull up your trash bag. Sometimes there's some in the bottom of your trash can. Could be. Could be. I don't know, because Maggie, I know, sometimes keeps extras in the bottom. Yeah, like if you pull your trash bag out, there might be some extras ready to be used. Might. They do. I'm looking. Maintenance room. There's two numbers listed here, 1114 and 1173. Okay. Bye. Okay. So from time 0 to time 1, what was my particle motion?
5.
We had a movement of 5. From time 1 to time 2.
-1.
Okay. I moved back 1, yes? However, when we talk total distance, that is a distance of 1. Well, because what is the question we're looking for? What is the total distance? So that's why I'm not using a negative. Does that make sense? And then from time 2 to time 3, we had how much movement? 5. And so, what is the total distance the particle travels? 11, because 5 plus 1 plus 5 is equal to 11.
What would kind of been the same?
The distance up above was talking about what is the position. So negatives were negatives because we want to know, okay, we went right 7 if we backed up, or like here, we went left 7, then we went right 3, okay, now we're at -4, like we want to know position. This is total distance traveled. Okay? Questions there? Okay. Example 3. The acceleration of a particle moving on the x-axis is a of t equals 4 pi cosine t. If the velocity is 1 at t equals 0, what is the average velocity of the particle over the interval 0 to pi? Okay, guys. We are provided, I'm just going to start writing down some information. We're provided in an acceleration formula, yes? Acceleration is 4 pi cosine t. The velocity is 1 at t equals 0. So that means v of 0 has to equal 1. So they gave me acceleration, they gave me that velocity. The question is, average velocity of the particle over the interval 0 to pi. Okay. Well, if they want to know the average velocity, what do I probably need to find? Velocity? We need a formula for velocity. How do we find velocity in relation to acceleration? Okay, normally acceleration is the derivative of velocity, so velocity is the integral. So in order to do velocity, I'm going to do the integral of 4 pi cosine t dt. What is the integral Well, first of all, 4 pi is just
4 pi.
4 pi. It's a constant. What's the integral of cosine t?
Sine t
Sine t. And then
plus 1.
we don't have boundaries, so officially for the moment I was going to say plus c. But how do I find c? They were told us up here that the velocity at 0 is 1. So officially that means if I plug 0 in here and set it equal to 1, that's me finding c. But also realize it's 0, 1. You guys have learned when it's 0, something, that's your c value, usually. I guess I shouldn't say always because there are the exceptions. But officially, you're plugging 0 in. So 4 pi sine of 0 plus c equals 1. But we know the sine of 0 is 0. And so, yes, it is true that c is 1. So that does make the equation v of t equals 4 pi sine of t plus 1. Okay. That's the velocity equation. What did it ask me to find? Average velocity. Huh? No.
You would take the integral from 0 to pi, and then, or would you just rate it from 0 to pi? You don't need another interval, or not interval, integral.
What did we learn yesterday? Did we do something with average yesterday? And I kind of tried to give you the hint that when we see the word average, when you're asked to find an average value, we're using that formula from yesterday. Okay, so they specifically are asking me for not just velocity, but average velocity. Now, average velocity, we had a formula yesterday, right? It was basically the integral, but what did I have to put out front?
1 over b minus a.
1 over b minus a. And what are my b and a here?
b is pi, a is 0.
Yeah, because the interval are your a and b, and so my interval goes from 0 to pi. So average 1 over b minus a, so 1 over pi minus 0 times the integral from 0 to pi of what? Well, if we're doing average velocity, what's our velocity formula? 4 pi sine t plus 1 dt. So as I said yesterday, when we learned how to do average value of a function, watch for the word average. There's your lesson from yesterday, Cassidy.
I watched it.
I say, you said you had the notes, so.
Did you watch it? Yeah, you said okay.
1 over pi minus 0 is going to basically be 1 over pi. What is the integral of 4 pi sine t? I can't put 4 on the outside because I also have this to integrate.
It would be negative 4 pi cosine t plus t.
Okay. Well, in here, on the 4 pi sine t, what I know is that there's a 4 pi, hold on, hold on.
I didn't care.
Okay, I'm trying to, tune in with me here. Okay, so integral of 4 pi sine t. 4 pi carries down. The integral of sine has to be cosine. The key is to figure out is it positive or negative. And the integral of sine is going to be negative cosine. And that's because normally the derivative of cosine is negative sine, so we have to have a negative in here somewhere. Plus What's the integral of 1?
T.
There's the t. Okay, because the integral of 1 is t, so plus t. Evaluated from 0 to pi. Okay, the 1 over pi I am keeping out front. What do we do first? Plug in what? There's no 2. Pi.
Not fancy. Not close.
Okay, so this is going to be negative 4 pi times, what's the cosine of pi? Negative 1. Plus t, what am I plugging in for t right this first time through? Pi. In the parentheses. And then what do I do before I plug in the 0? Minus. And so this time it's negative 4 pi times, what's cosine at 0? 1. Plus t, so plus 0. Good news is it looks messy, but it's really not.
Dividing out pi.
Yeah, and I was just going to use that at the end. If I just clean up what's here, negative 4 pi times negative 1 is 4 pi plus this pi makes this first part 5 pi minus negative 4 pi times 1 is negative minus negative 4 pi, so plus 4 pi. So I end up with 1 over pi times 9 pi. What happens when you do 1 over pi times 9 pi? Pi's cancel and we just have 9. This is an average velocity. What kind of label would you label with velocity?
Units over seconds.
Yeah. It's units per second. We don't have a specific measurement of units, so I get it. I mean, meters per second, we just don't, nothing tells us this is meters, but you have the right setup.
What would be the other possibility for
Feet
Feet per second,
or kilometers.
inches per minute. I mean, nothing says it has to be,
really be anything?
yeah,
Anything
a distance
over time.
over a time. Okay, example 4. I have one on the back side to do too, don't I?
Yeah.
Oh, you have a lot of money.
I do. I think part of it is I just wrote big, but. Okay, example 4. The velocity function for a particle moving along the x-axis is given by v of t equals 2 pi cosine pi t. For what values of t from 0 to 2 is the particle stationary?
Stationary?
So when
Yeah,
the
what's
change
stationary
in
mean?
distance equals 0.
Is it better like staying in height?
Yeah.
Velocity equals 0.
Particle stationary, when is the particle stopped?
So velocity equals 0.
Okay, so we're back to that whole, when the velocity equals 0, that's when the particle pauses. Whether it's turning going the other way or then continuing in the way it was going, velocity equals 0 is what we need to look at. So we're given v of t equals 2 pi cosine of pi t, and we need to know when this velocity equals 0. Now, so how do I solve this equation? If it's 2 pi cosine of pi t equals 0,
Go up to 2 pi.
okay, so to get cosine by itself, officially I can divide by the 2 pi out front, but on the other side, when I do 0 divided by 2 pi, I'm going to end up with 0. So now I'm at cosine of pi t equals 0. I'm actually kind of doing this in pre-cal right now because we were just solving equations.
You can take the inverse and then divide by pi.
Okay, yeah. what I had in my mind was asking, where does cosine equal 0? Okay, like ignore the pi for a moment. I don't know if you remember from doing this from last year or not.
T equals 1/2 and T equals 3/2.
Okay, and officially, we could keep going. And I'm going to talk about that way. But so yeah, when cosine equals 0, we know that's going to happen. You start high on the graph, right? You cross at pi over 2. You cross at 3 pi over 2. If we keep going, where would you next cross? 1 pi over 2, 3 pi over 2, 5 pi over 2. We could keep going on and on, right? And depending on your interval will depend how far you want to go. Now, as we look at this, where does cosine equal 0? Here's the catch. What's actually in here? It's not just when does cosine of t equal 0, it's pi t. And so we're going to set pi t equal to, okay, the first time we said was 3 pi over 2. I can set pi t equal to, that wasn't the first time, pi over 2. Got my numbers wrong. 3 pi over 2. I'm going to go one more. I think I just need to go one more, yeah. Okay. And this is just kind of a beware thing, but I'm looking for any place cosine equals 0. So cosine equals 0 at pi over 2, at 3 pi over 2, we can keep going, 5 pi over 2, 7 pi over 2. Here's the deal. You have to be able to list all of them on that interval. Now, I really just need to know what t is. So if it's pi times t, how do I find what t is? Divide by pi, which is also multiplying by 1 over pi. What do I end up with here? When I take pi over 2 and I divide that pi away, I have 1/2. On this next one, if I have 3 pi over 2 and I divide the pi away, I now have 3 over 2. On this next one, if I divide pi away from 5 pi over 2, I'm going to have 5 over 2. And technically, we could keep going. Now, this was for what values of t from 0 to 2 is the particle stationary. So what answers do I need here? 1/2 and 3/2. The reason I did this, though, is because depending on what you're multiplying or dividing by, could something like the next one end up in your interval? And it could. I just want you thinking that, okay, you don't just stop once around the unit circle. You could need to go more than that. Okay? So anytime you have something other than just your traditional variable in there, I find what would go in there and then set that equal to it. But it is just, in that case, dividing the pi out. Okay. One last one on the back side. I really have things written bigger than I took up like the whole page, but it's not. I think some of it I just wrote big, you know. I had the room, so I took advantage of it. Okay. What is the total distance traveled to the left by the particle in example 4 between times equals 0 and 2? So, if you go back to, that's the example we just did, right? And that is the example where we were given v of t equals 2 pi cosine of pi over t. Okay. Now, did you catch what all they asked? What is the total distance? Specifically what? Traveled to the left. So do I want to know Yeah, he did. So I was like, travel to the left. So total distance, travel to the left. Does it matter where it travels to the right? No. And this is between times 0 and 2. Now, in order to know what's going on here, I mean, on the front side, we just looked at where's the particle stationary, right? You have to know what's happening in between those points. So can you guys visualize your cosine curve? This is the easiest way for me to talk about this one. Cosine curve starts high, crosses through, minimum, starts or ends high, right? And this is your cosine curve. Now, we are specifically looking on what interval? From 0 to 2. So if I call this 0 and this 2. What are the two places here? We had the particle was stationary at what times?
Pi over 2 and 3 pi over 2.
Well, but it ends up being the times of just 1/2 and 3/2, right? Where are those represented on my graph?
The zeros.
The zeros is in the place we cross the x-axis. So at 1/2 and at 3/2. Total distance traveled to the left. Remember, this is a velocity graph. When is my particle traveling to the left? When the velocity is negative, and my velocity is negative when it is below. So, the idea here is that I have
So you need the integral from those two times.
negative velocity is when it's going to be moving left, and that negative velocity is happening between 1/2 and 3/2. That was my reason for drawing the graph here. I wanted you to be able to see that. So, total distance, we need to do the integral of velocity, because we want distance, right? And it's going to be the distance from 1/2 to 3/2 of our velocity function, which is 2 pi cosine pi over t dt. And again, we're already taking up lots of space there. And again, I knew my 1/2 and 3/2 because that's when my velocity is negative. So that's the only section of this function or graph I care about. Okay. So, my 2 pi is a constant, yes? I'm just going to put it out front. What is the integral of cosine of something?
Negative sign.
Wait. Integral of cosine? It's not negative, it's just positive sign, yes? I'm double checking myself here.
Yeah.
Okay. So integral of cosine is sine. Now, there's a pi t here.
Divide
If-
by the pi.
Yeah, if we were taking the derivative, we do times pi. Since we're taking the integral, we're going to compensate, and we're going to say divide by pi. So I'm going to say 1 over pi times sine of pi t. And then it's evaluated from 1/2 to 3/2. Kind of like the idea when it's the integral of cosine of 3t. You guys remember we've done that lately, right? If it's the integral of cosine of 3t, it's sine of 3t, but then times the 1/3 to compensate for that chain rule derivative.
So
What do you notice with the 2 pi and the 1 over pi? 2 pi and 1 over pi will cancel, and so I just have a 2. And then plug stuff in. Sine of pi t is going to be sine of We plug the 3 halves in. Okay. Sine of 3 pi over 2 minus sine of, this time I'm plugging in 1/2 times pi. So pi over 2. Sine of 3 pi over 2 is -1 minus sine of pi over 2 is +1. This ends up being -4.
So it travels 40.
Okay, yep. And so that negative right there, right? That negative sign indicates the area is below the x-axis, so the particle moved left. And I'm going to write that down. Negative sign indicates area is below x-axis. So, particle moved 4 units left. That is the key more than anything. I need you to realize that that is 4 units left. I have a couple homework changes I'm going to throw on the bottom here. (22 through 25) become 5 through 8 from 86. 16 becomes 23 from 87. Yes, that is it. Sorry, my eye's doing something weird.